We need to optimize the following Boolean functions by means of a 3-variable K-map. We can see that we have our variables a, b, and c with x, y, and z in this column. We are going to write out our function over here, and then our indices we'll write out here. We will have index 1, index 2, index 3, 4, 5, 6, 7, so the length of each of our things is 7. Now, previously we filled out this truth table in a certain way. When I use K-maps, I like to look and actually make the map first and then fill in the truth table. Because if we make our map like this, and we'll look at part A first, we have an x, y, and then we will have the z up here. We're going to split it like this, and then we're going to draw 8 boxes. So we have the height of 4, and then we have a width of 2. And then we could split this down the middle like this, so our width is 2. Now, what we're going to want to do is have all the different possible types. You know, our z is going to be 0 and 1. Those are the only 2 possible types. So when we look at our truth table, we're going to fill in 0, 1, 0, 1, 0, 1, all the way down the column. When we look at our x, y, well, the different types we can have here we know are 0, 0, 0, 1, 1, 0, 1, 1. And so, when we look at our column, we are going to have a 0, 0, 0, 0, and then a 0, 1, 0, 1, so these we write out twice, a 1, 0, 1, 0, and then a 1, 1, 1, 1. And we filled in all of the columns of our truth table. There is no repetitions. This is all correct. So now we are going to look at part A. I'm going to write this in red. We have the min terms, and we know the min terms are going to be where our function is a 1. So at 2, which is here, 3, 4, and 7 we have 1s, and the rest we are just going to have 0s. So let's fill in our K-map. We have 0 here, and then 0, 0 here. And so what this means is that we're going to have a 0 here. In fact, we can actually look at the indexes of our K-map. This is going to be index 0. This is index 1, 2, 3, 4, 5, 6, and lastly 7. This can vary depending on your actual K-map, but if you do it like this, it will look like this. So now we can just plug things in. We're going to have a 0, 0, 1, 1, 0, 1, 0, 0, 1. So this is going to be our map. And now, what we're going to need to do is find the Boolean functions for this. Well, we know in a K-map, we can look up and down, and we can look left and right. So I'm going to start this off with indexes 2 and 3. We can see they're right next to each other, like this, so let's analyze it. We can see that it's going to be a 1 no matter what column of z it's in. And so we are going to disregard z when we are looking into making our Boolean function. What we are going to look at though is this row. When it's in a row like this, normally, and they're both on, we only look at this right here, the row. So we can see that it's going to be an x naught because it's a 0, and the naught of something is 0. And then we're going to have a y like this. So far, our function is going to be f is equal to our x naught y. Now let's look at another part. Well, we can see that we have this lonely 1 right here. In looking at it, well, we can look at this one above it right here. Looking at this one above here, we can see that they're both 1s, and this column that it's in is a 0. So if we look at z, it's going to be z naught, because it's the opposite of this z. So we have a 0 here, and we have 2 1s here, meaning that it's the opposite, so we look at z naught. Now we're going to look at these 2 rows. So we have 0, 1, and 1, 0. Well, for this, right here, we can see that our x is 1, and our answer is 1, so we're going to have an x here. And next, our y is 0, well, our answer is 1, so we're going to have a y naught, like this. Now, we are going to look at this 7 right here. So index 7, we have a 1. Well, when we look at this, we can see if we look in the same column as we have right here, we are going to have the z as 1, and since our output is 1, we know our z is like this. And now let's look in our row. Well, looking at here and here, since this is where we paired it, we can see that the x's are different. So in this one we have a 0, in this one we have a 1, and this corresponds to this one and this one which we are comparing it with. So we're going to not look at the x, but look at the y, because we have y is 1 and y is 1, they're both the same. And since y is 1 and y is 1 in our row, and it's that in our output, we can just have a y here. So that is going to be the answer for part A. Next we're going to look at part B. So in this function, we are going to have 0, so 1 is here, 4, 1's here, 5, and 6. That means the rest of these are 0. We're going to draw our k-map again. We have our x, y, we have our z, and now we can start this off. Remember, it's 4 rows down and 2 columns over. So it's going to look something like this, and then we are going to have the same thing, 0, 1, and then 0, 0, 0, 1, 1, 0, 1, 1. Now let's fill this in. We know we have 1 here, 0, 0, 0, 1, 1, 1, 0. So this is what this k-map will look like. Now we can start solving for it. So I like to always look at the ones that are across first. So we're going to look at this one right here. We have f is equal to, and when we look at this we can see it's independent of our z. It doesn't change the output for whichever z column we're in, so we're not going to include the z column. We're just going to look at this row. We have an x and then our y naught. So that's that done. Let's look at the next one. Well, for the next one, we have this 1 out here. Now, we could scoop this up and have it continue over this way, but we can't because this is a 0, 0 and this is a 1, 1. We can see that they're totally different. So we will look at it in terms of this one, and then we can also look at this one with it as well. So when we're in here, we can see that it's going to be the opposite of our z. So we're going to have a z naught, and then what we can see is our x's for this and the one that we're comparing it to are opposite, so we are not looking at them because this is a 0 and this is a 1, so that's not reliable. But what is reliable is this y is 0 and y is 0, since they're both zeros. However, our output is 1, so we need to take the naught of y. That means in our answer we're going to have a y naught z naught. Next we have this one right here, and we can look at it with this one right here. So looking at this, what can we tell? Well, our z is equal to 0 in this column, and since it's equal to 0, that means that we need to take the z naught since our output is 1. Now looking at these rows, we can see that our x is the same, but y is not. So we are not looking at the y, we are only looking at the x. And we can see that our x's are 1, and the output is 1, so that means we're going to have an x times a z naught. And that is how you would solve for part B. For part C, I've gone ahead and drawn the k-map, and now we need to write down our values. We're going to do this in green. So we are going to have a 1 at 0, we are going to have a 1 at 2, we are going to have a 1 at 4, 1 at 6, and 1 at 7. That means the rest of these are just zeros. So when we fill in our map, we go from left to right, 1, 0, 1, 0, 1, 0, and lastly 1, 1. So looking at part C, first thing that I notice is, well, all of these in this column are 1s. And also what I noticed is that in part C, instead of x and y, we have a, b, c. That doesn't change anything, it just switches out our labeling. So when we look at this, we can see that we're not going to be looking at our a and b for this column, because when we look down here, we can see everything differs if we were to include all 4. The only thing that remains the same is this c. And we can see that our c is in the 0 column, so we're going to take a c naught here. So this entire column can be represented as a c naught. We do have one more to look at, and this is the 1 right here. And for this 1 right here, well, what I'm going to do is I'm going to pair it with this one and analyze it. We can see that if we pair it with this 1 it's not going to be decided by this C, because this column is 0 and this column is 1, but they're 1 in both columns. So we're only going to be looking at this row. And this row is 1, 1, so A and B. So our answer for here is going to be AB. And the answer for the entire C is going to be F is equal to C naught plus AB. In part D, we have 0, 1, 3, 4, 6, and 7 as our min terms. So we're going to write this out here. This is what our truth table will look like, and now we can start filling it in from right to left. We have 1, 1, 0, 1, 1, 0, 1, 1. Now looking at this, we have multiple ways we could go about solving this. I mean, we can look at this column, we can look at this row, we can look at this column, this row. There's many different ways. What I'm going to do is focus first on this column right here. So we're going to say that our function is equal to, and we're in the C column, and the C column is 1. So we're going to say that we have a C here. And then I'm going to look at our A column, because, well, we have a 0, 0 like this. And since we have a 0, 0 and our output is 1, 1, we're just going to take the A naught of it. Now we're going to look at the next one. Next one I can see that's easiest, well, it's this right here. We have this 1, 1 like that. And so what I'm going to do is I'm going to say we have this C right here, and it's split across 0, 1, and we can see that the output is 1, 1 for both. That means C has no part in this. So we're only looking at our AB. And we can see that AB is both 1, 1, so we're just going to add AB. Now we need to look at this and this right here. So what I'm going to do is I'm going to say, well, they are in the same column. So we're going to take this one, compare it to this one. And so in here, I'm going to say, well, if we look at C, it's 1, 1, so we can look at C since they both the same output, and it's in the opposite column. So we're going to have a C naught here. And then when we look at the rows, we look at 0, 0, and 1, 0. Well, we can't look at A because we have a 0 and then a 1, and we can't compare two different things. But our B has a 0 and a 0. And since our B has a 0 and 0, and our output is a 1, 1, we are going to have a B naught in here. And that is all of the different 3 variable maps for these 4 functions.